All right, so this video is going to go over pages 23 through 26. So we're going to be going over average velocity. So besides graphical method, which is when we just connected the 2 points and found the slope to find average velocity, now we're actually going to use a formula given off word problems. So your average velocity, so your V average, is going to be your total displacement. So total displacement over your total time. So the key words there are total. Okay, so we're going to have multiple displacements and multiple times. Okay, so you have to have displacement and you have to have time in order to do this. Okay, so this basically looks a lot like our equations we've been using. So V equals d over t. But now we're actually just using total displacement and total time. So we're going to look at example number 1. A car goes 100 kilometers in 0.9 hours. Then 80 kilometers in 0.7 hours, and then 150 kilometers in 1.5 hours. What is the car's average velocity? So if you're ever having trouble figuring out what things did we give you, you've only got 3 options right now. You've got velocity, displacement, or time. Okay, so if I have displacement, that's where I'm looking at a change in position. Okay, so that'd be like meters, kilometers. Okay, time, that should be kind of more common sense, hours, minutes, seconds. And then velocity would be like kilometers per hour, meters per second, miles per hour. Okay, so you kind of start figuring out the units for velocity and displacement. So what happens is I gave you displacement 1. So displacement 1 was 100 kilometers. And then my time 1 was 0.9 hours. Okay, so right now what I'm doing is I'm just organizing what I have. Okay, so that was my first segment. My next part is my displacement 2 is 80 kilometers. And my time 2 is going to be 0.7 hours. And then lastly, my displacement 3 is going to be 150 kilometers. And then my time 3 is 1.5 hours. Okay, so this just kind of helps you figure out what you have, what you're looking for, and it keeps things nice and organized. So what's the car's average velocity? So remember, average velocity is going to be your total displacement over total time. Now, do we have displacements? Yes. Do we have times? Yes. So all we gotta do is just plug it in. So I'm gonna add up all those displacements on top. So 100 plus 80 plus 150. So those are your displacements. And my times on bottom, I'm gonna do 0.9 plus 0.7 plus 1.5. Okay, so add all those up, top and bottom, and then just divide them, and you're going to get 106.45 kilometers per hour. And that would be your answer right there. So it's really not that difficult as far as when I give you displacements and times. All you got to do is just plug it in. But now we're going to go into a couple examples where I don't necessarily give you a displacement or a time, and you just have to find it. So we're going to move on to the next page. A motorcycle travels 120 kilometers per hour for 2 hours. Slows down to 105 kilometers per hour for 1 hour, and then speeds up to 135 kilometers per hour for 0.5 hours. So bold thing here is you cannot just add your velocities up and just divide by 3. Okay, now that technically that is an average, but that is not how you calculate average velocity. So what I'm going to do is, before I start kind of panicking because I've got all this stuff going on, I'm just going to clean things up and organize it. So velocity 1 is going to be 120 kilometers per hour. My time 1 is 2 hours. So if you notice, what I'm missing is I'm missing my displacement. And in order to find average velocity, you need displacement. So we're going to have to find that. I'm going to find it here in a second. So that's our question mark. Then we slow down. So my velocity 2 is 105 kilometers per hour. And my time 2 is 1 hour. And my displacement 2, I don't know. So that's a question mark. And then my velocity has speed back up to, so my velocity 3 is going to be 135 kilometers per hour. My time 3 is going to be 0.5 hours. And I don't know what my third displacement is. Okay, so in order to find displacement for each one of these, we can still use the same equation we've been using, which is V equals d over t. Okay, or if you like the circle trick, you can use the circle trick where we have velocity on bottom left, displacement on top, and then t on the bottom right. And you would just cover up what you're looking for. So I'm going to plug in. So I have velocity is going to be 120 equals D I don't know, so I'm going to leave it as D, and then T is going to be 2. Okay, so we had multiplied both sides by 2, so my displacement 1 is going to be 240 kilometers. Now, that's me just using the equation part. If you're using the circle part, if I'm looking for D, I would cover up this D, and that would tell you that it's velocity times time. Okay, so either way works as long as we get the same answer. Then I'm going to do it for the next one. So I have a velocity of 105 equals D2, I don't know. My time 2 is 1. So this is going to be easy. So 105 times 1. So that means displacement 2 is going to be 105 kilometers. Then my third one of 135 equals displacement 3 over your time, 0.5. So multiply both sides by 0.5. And you're going to need a displacement of 67.5 kilometers. Now you have times. So we've got times. And now we have our displacements. Now you can actually solve for our average velocity. So our average velocity, we're going to add up all those displacements. So 240 plus 105 plus 67.5. Then add up your times on bottom. 2 plus 1 plus 0.5. And we're going to get 117.86 kilometers per hour. Now, one thing I do want to talk about is once you kind of get in this habit of looking for something, I see some students try to make the more simple problems like we just did more complicated. So if we go back to this problem we just did, okay, I do not need to find velocities for each one of these segments. So I do not need to find V1. Okay, so V1, so that'd be, I do not need that. I do not need V2. I do not need V3. So if you're solving for those, I mean, it's not going to hurt anything, but it's not going to help you find the answer. All you need are displacements. So do I have displacements? Yep. Do I have times? Yep. That's all you need. Okay, so you do not need to find velocities for each one. Now in this problem, we had velocity and we had time. We just needed displacement, so that's why we had to find it. Okay, so on number 3, a car travels 1 kilometer through a town at 50 kilometers per hour. Okay, so my displacement 1 is 1 kilometer. My velocity 1 is 50 kilometers per hour. That means it didn't give me a time, so I don't know what my T1 is. Okay, then travels down the highway for 1 kilometer, so my displacement 2 is 1 kilometer. Okay, at 100 kilometers per hour, so my V2 is 100 kilometers per hour. And I did not tell you time 2. And we need time. We have displacement, so we're good there. We just need the time. So we're going to plug in. So we got V equals D over T, so 50 equals 1 over T. So this is where you got to be careful. You can do 2 ways. One, you can switch these two. Okay, if anytime there's a variable on bottom, you can switch with the other side. So it would be 1 divided by 50. If you were doing the whole circle trick over here, so you've got V, D, and T, and you're looking for T covered up, and that would be displacement divided by velocity. So 1 divided by 50 is going to give me 0.02 seconds. Now I'm going to do that for my next one. Okay, so I have 100 kilometers per hour equals 1 over T. I can switch these two. So 1 divided by 100, so it gives me a time of 0.01 seconds. So now, do I have displacements? Yep. Do I have times? Yep. So now I can actually use my average velocity. So we're going to plug in. So V average equals 1 plus 1, so my total displacement over my total time. So 0.02 plus 0.01. Okay, and that's going to come out to 66.67 kilometers per hour. Okay, so in that case, we had to find time. We didn't have it. In the problem before it, we had to find displacement. We didn't have it. And then the problem before it, we already had them, so all we had to do was just plug in. Okay, so let's move on to the next page. So calculate the average velocity as the total displacement per total time. A person walks 5 kilometers east, so watch out for those directions, in 2 hours. Okay, so my displacement 1, 5 kilometers, and then time 1 is going to be 2 hours. Then 1.5 kilometers east. Okay, so my displacement 2 1.5 kilometers. And then time 2 is 0.5 hours. And then finally 10 kilometers east, so displacement 3. Okay, so that's going to be 10 kilometers. And my time 3 is going to be 3.25 hours. Now, just watch out for your directions here. They are all east. Okay, so that means there's not going to be really much of an issue here. Okay, so I have displacements, I have times, so all you got to do is just plug in. So V average is going to be my displacement, so 5 plus 1.5 plus 10, all over your total times. Okay, and those are going to be 2 plus 0.5 plus 3.25. Okay, so we're going to find our top total, find our bottom total, divide. So this would be 2.87 kilometers per hour. Now, if we give you directions in the problem, you need to make sure you keep those in the answer. So I'm going to add that east on the end of that answer. Okay. Number 2, a person walks 5 kilometers east in 2 hours. Okay, so I have my displacement 1, time 1. I'm not going to write out the organizing part for this since it's basically the same thing. Okay, but then I went 1.5 kilometers west. So key thing there is west. It's bolded. Okay, I have my second time, and then 10 kilometers east and 3.25 hours. So I'm going to do the same thing. So V average equals 5. Now I'm going to minus that 1.5 since it's going west. So if it's going in the opposite direction, you can't just add it. But then we go east again, so I'm going to add that 10 back to it. Then I'm going to take my time, so it's going to be 2. Now this is where you got to be careful is you cannot have negative time. So even though you went west and we subtracted that, it's still adding that 0.5 hours to the trip. Okay, so we're not going to subtract time because you can't go back in time. And then my last time was 3.25. So do the math there and we get 2.35 kilometers per hour, and that is going to still be east. So even though we went west a little bit, you still ended up east. Number 3, a car is driven 100 kilometers per hour for 1 hour. So V1 is 100 kilometers per hour for 1 hour. So I know T1 is 1 hour. That means I don't know displacement 1. So that's what we're going to come back for. Then 50 kilometers per hour for 0.5 hours. So V2 is going to be 50 kilometers per hour. And T2 is going to be 0.5 hours. So we don't know displacement 2. Then 80 kilometers per hour. So velocity 3, 80 kilometers per hour. T3 is going to be 0.75 hours. And displacement 3, we don't know. Okay, so what we're going to do is you can use your equation. You can do the whole V, D, T circle if you want, or V equals D over T. So if I'm looking for displacement, I would cover up displacement. So that's V times T. So V times T, 100 times 1, it's going to be 100. So there's my D1. D2, 50 times 0.5. So D2 is going to be 25 kilometers. And then 80 times 0.75. So my displacement 3 is going to be 60 kilometers. So now, do we have displacements? Yes. Do we have times? Yes. So now we can actually plug in. So V average is going to be your displacement. So 100 plus 25 plus 60. All over our time. So 1 plus 0.5 plus 0.75. And that's going to give me 82.22 kilometers per hour. 4, a runner jogs 2 kilometers at 5 kilometers per hour. Okay, so I gave you velocity 1 is 5 kilometers per hour. I gave you displacement 1 is 2 kilometers. So that means I don't know what time 1 is. So there's a question mark. Then runs 1 kilometer at 7 kilometers per hour. So V2 is 7 kilometers per hour. My D2 is 1 kilometer. And my T2, I don't know. So I need to find these times before I can do anything. So we do our little circle thing. So I'm going to draw my circle. So V, D, T. So I'm looking for T, so I'm going to cover that up. So D divided by V. Okay, so 2 divided by 5, and that's going to give me a time 1 of 0.4 hours. And then over here, I'm going to take that 1 divided by 7, so T2 is going to be 0.14 hours. Okay, so do I have my displacements? Yes. Do I have my times now? Yes, so now we can plug in. So my displacement's 2 plus 1 over your times now, so 0.4 plus 0.14. And that's going to come out to 5.56 kilometers per hour. Number 5, you drive in a straight line at 15 meters per second for 10 minutes, and then at 25 meters per second for another 10 minutes. Is your average velocity A, B, or C? Explain. Okay, so now, could you probably do this mentally and stuff? Yes, but I'm going to kind of go through. This is a good problem for units. If you notice, your velocity is in meters per second, but your time is in minutes. Okay, so we have to have those in congruent with each other in order to be able to use them. So my velocity 1, 15.0 meters per second. Now my T1 is 10 minutes, but I need it in seconds, so 10 times 60 is going to give me 600 seconds. So that means I am going to be looking for displacement 1. I don't know. Okay, then my next one, I have velocity 2. That is 25.0 meters per second. My time 2 is still 10 minutes, so 10 times 60 is going to give me 600 seconds. And displacement 2, I don't know. Okay, so if you do your V equals D over T, so V, D, and T, I'm looking for D, so cover it up. So that's going to be V times T. So 15 times 600. So displacement of 1, so D1 becomes 9,000 meters. And then next one, if we do 25 times 600, that's going to give me a displacement 2 of 15,000 meters. Okay, so my V average is my displacements added up, so 9,000 plus 15,000, all over my total time, so 600 plus 600, and that's going to give me 20 meters per second. Okay. 6, you drive in a straight line at 20 meters per second for 10 kilometers. Okay, so this is where you got to kind of watch out again. Okay, you're in kilometers, but we're in meters per second. So there's 2 ways you can do this. You can convert to kilometers per hour if you want to, or you can just convert the kilometers to meters. I'm going to convert to meters. So velocity 1 is 20.0 meters per second. My displacement 1, so there are 1,000 meters in 1 kilometer, so that's going to be 10,000 meters. So that means I do not know time 1, so that's my question mark. Then at 30 meters per second, so V2, 30.0 meters per second. For another 10 kilometers, so my displacement 2 is going to be 10,000 meters. And time 3, I don't know, so we're going to find that. So we're going to do our V, D, T. Sorry. I'm looking for time, so cover it up. So it's going to be D divided by V. So that 10,000 divided by 20. So time 1, so 10,000 divided by 20 is going to give me 500 seconds. And then time 2, I'm going to take that 10,000 and divide it by 30. And I get 333.33 seconds. Okay, so now I have times, I have displacement, so I can plug in. So V average is your displacement, so 10,000 plus 10,000 all over your total time. So we're going to take that 500 seconds plus 333.33 seconds, and we should get 24 meters per second. Now 7, after a tennis match, the players rush towards the net to congratulate each other. If they're each running with a speed of 3 meters per second, are their velocities equal? How do you know? Now technically, in this case, speed and velocity are technically kind of the same thing. When it comes to the equation part, they're pretty much the same. It's when it comes to the graph, whether you're using distance or displacement, that's where they can differ. But in this case, we can honestly say that speed and velocity are the same thing. Okay, but if you look, you have one player going towards the net this way, one player going towards the net this way. And so we know velocities are vector. That means they care about direction. So that means one has to be going a positive 3 meters per second, and one has to be going negative 3 meters per second. So are their velocities the same? No. Their speeds can be, because they're both going 3 meters per second, because remember, speed doesn't care about direction. But the answer for velocity is no, because you have a positive and a negative now, which makes them different. Okay, number 8, an ant starts at a location 2 centimeters left of the origin. Okay, so I'm going to kind of just draw a number line. And we're going to start it at 0, and then we're going to -1, -2, -3, -4, -5. That should be far enough. And we got 1, 2, 3, 4, 5. That should be far enough. Okay, so it starts at 2 centimeters left of the origin. So remember, your origin is right here. It's at the 0. So we're starting, let me use a different color for this one. We're starting at -2. And then it walks to 5 centimeters to the right. Okay, so we're going to go all the way. So 1, 2, 3, 4, 5. So we land on the 3. Okay, and then another 8 centimeters to the left. Okay, so we're going to start at the 3 and we're going to go 8 to the left. And you should end on -5. Okay, so this is where we ended right here. So what is the ant's total displacement? So remember, displacement is your final position minus your initial position. Okay, so my final position was -5. My initial was -2. Okay, so -5 minus a -2, that becomes a positive. So -5 plus 2 gives me -3 centimeters. Now you could say 3 centimeters to the left, or -3 centimeters would work. But then if I ask for distance, oops, I don't know what I just did there. Give me 1 second, let me figure this out. There we go. So if I was looking for distance, I wouldn't care about direction. I would just add all it up. I would do 5 to the right plus 8 to the left. So my distance would just be 13 centimeters. And that would be your answer. All right, and that ends that video.